In this video, I'm going to show you how to solve a system of equations using the substitution method. Now remember, a system of equations are two or more equations. The first example, I'm going to show you where one equation already has a variable by itself. Notice that is slope-intercept form. It's set equal to y. You could also have an equation where it's set equal to x. It doesn't matter in substitution. Then we're going to have another equation that's in standard form. And what I like to do for substitution is to create a big T-chart. That helps me keep things organized and nice and neat so I don't make any careless mistakes. I start with the side where the one equation is in slope-intercept form. And I'm going to circle the expression 2x plus 1. 2x plus 1 equals y. So that means I can substitute in 2x plus 1 for any y. And that's what I'm going to do. I'm going to take this expression and I'm going to substitute it into the other equation for y. So over here on the right-hand side, I'm going to have x plus 3 times y equals negative 11. So what I did was I created a little bit more room to plug in the expression. So I took y out and I'm going to put in 2x plus 1 inside the parentheses. Now I have a multi-step equation where I need to solve for x. So remember, when you're solving a system of equations, you are trying to find the ordered pair x comma y. I need the x value and I need the y value. So if I can solve this multi-step equation, I'll have my x value. Sometimes you solve for your y value first. So keep that in mind. So my first step in solving this equation would be the distributive property. I need to distribute in my 3. Bring your x down, don't forget it. 3 times 2x gives you 6x. 3 times 1 gives you 3. Keep those equal signs lined up. Bring down the negative 11. Your next step is to combine like terms. X plus 6x gives you 7x. Plus 3 equals negative 11. Your next step is to undo what's being added or subtracted to x. So 3 is being added, so I'm going to undo that by subtracting 3 from both sides. These opposites cancel each other out, leaving me with 7x on the left-hand side. This is a negative 11 plus a negative 3. Negative 11, negative 3 combined gives you a negative 14. The last step is undoing a multiplication or division. This is 7 times x. So I'm going to divide by 7. Divide by your coefficient of x. 7 divided by 7 leaves you with 1x. Negative 14 divided by 7 gives you negative 2. So x equals negative 2. So I've got half of my system solved. I've got my x, now I need my y. Well, notice I don't have any work on this side just yet, so I'm going to take this negative 2. Notice the negative 2 equals x. So I can substitute that in for any x. And that's what I'm going to do. It's going in for that x right over there. So y equals 2 times x plus 1. In that parentheses, I'm going to put in that negative 2. This side's a little bit easier. You're not really solving an equation. You're simplifying an expression because 2 times negative 2 gives you negative 4. Negative 4 plus 1 gives you negative 3. So y gives you negative 3. So my solution to this system is negative 2 and negative 3. That's the solution of this system. The next type of problem that I want to show you using substitution is where neither one of the equations are set to a variable. So I'm going to take 2x plus y equals negative 10, and I'm going to take x plus 2y equals 1. And again, I'm going to create my t-chart. I like creating a t-chart for substitution. A little trick is substitution. Make a t-chart. Just a silly way for me to remember it. Now, both of these equations are in standard form. Standard form is ax plus by equals c. We don't really use standard form that much, but that's what it looks like. Now, for this type of problem, I'm going to get one of these equations and get a variable by itself. It doesn't matter. You could get the y by itself. You could get the x by itself. Just for fun, I'm going to start with this equation, and I'm going to get x by itself. I'm going to isolate x. That means I'm going to subtract 2y from both sides. So if I subtract 2y from both sides, x equals 1 minus 2y. This equals x. 1 minus 2y equals x. Well, that means I can substitute this in for any x. And that's what I'm going to do. I'm going to bring this over here and substitute it in for x. Now, I could have easily taken this equation and solved for y and substitute that expression over here. So you've got choices. 2 times x plus y equals negative 10. So I'm leaving enough room to put in the parentheses 1 minus 2y. 1 minus 2y substituted in for x. So on one side, you're going to have an equation that you need to solve. On the other side, you're going to have to simplify an expression. So here we're going to solve for y. Do the distributive property. 2 times 1 gives you 2. 2 times negative 2y gives you negative 4y. Bring down your y. Bring down your negative 10. Next step is to combine like terms. You have a negative 4y and you have a 1y. Negative 4 plus 1 gives you a negative 3y. Next step is to undo addition or subtraction. Well, 2 is being subtracted here. That's a positive 2. Positive 2. So I'm going to subtract 2 from both sides. Subtract 2. Remember that negative symbol's in front of the 3. So that's a negative 3. And we'll deal with that in just a minute. Positive 2 and negative 2, those are opposites, so they're going to cancel out. Negative 3 equals negative 12 on the other side. Negative 10 combined with negative 2 gives you negative 12. Now I'm going to deal with that negative 3. That's negative 3 times y. So I'm going to undo the multiplication and divide by negative 3. Negative 12 divided by negative 3 gives me a positive 4. So that gives me a part of my solution. That gives me the y part. Remember, every ordered pair is x comma y. So I solved for y first in this situation. So I got the 4. Now, 4 equals y. So I'm going to substitute that in for the y. So remember, one side we solve an equation. The other side we just simplify an expression. X equals 1 minus 2 times y. But instead of y, what am I going to plug in? What am I going to substitute in? 4. So then just use your order of operations. Negative 2 times 4 gives you a negative 8. You always want to multiply before you add or subtract. 1 minus 8 gives you negative 7. There's my x value. So my solution to this system is negative 7 and negative 4. It is an ordered pair with parentheses around it. The last example is actually the easiest. I'm going to show you where both equations are set equal to a variable. Let's say you have y equals x plus 5, and you have y equals negative x plus 3. Both of these are in slope-intercept form. I could graph them, or if I don't have graph paper available, I could just solve by substitution. Always want to use my t-chart. It helps. So since they're both set equal to y, it really doesn't matter. All we're doing is picking one. I'm going to pick this one. This expression, negative x plus 3 equals y. I'm going to substitute this expression in for y. Basically, what I'm doing is I'm going to drop the y's and set these expressions equal to each other. So negative x plus 3 equals x plus 5. Again, when they're both in slope-intercept form, I'm just taking these expressions, x plus 5 and negative x plus 3, and setting them equal to each other. Notice we talked about before, when your slopes are different, you're going to come up with one solution, and we're going to figure out what that one solution is. So we need to solve this equation. In this equation, we don't have the distributive property. We don't have combined like terms. However, we do need to get the variable on one side. So it's always easier to pick the smallest variable. This negative x is smaller than a positive 1x. So I'm going to add an x to both sides. These opposites cancel out. That leaves me with 3 equals x plus x, which is 2x. Bring down my positive 5. Then I want to undo addition or subtraction. So I want to subtract 5 from both sides. Bring down some more paper so I don't run out of room. There we go. So I'm going to subtract 5 from both sides. 3 take away 5 gives me a negative 2. These opposites cancel each other out. Then I want to undo this multiplication here by dividing by 2. So remember, that's a negative 2. Negative 2 divided by 2 gives me a negative 1. So my x is negative 1. So I've got my x part. Now I need my y. Well, I take this negative 1 and I can plug it into either one of these. It doesn't matter. But I've got space over here. So I'm going to put it in for my x. This equals x. It substitutes in for x. So y equals negative on the outside, negative 1 on the inside. 2 negatives give me a positive 1. 1 plus 3 gives me 4. So there is my solution to this system. So I've given you 3 types of examples on how to solve by using substitution.